Welcome back to the Private Cloud Jumpstart, creating and managing a private cloud with System Center 2012. We're now on our 9th and final module. We hope that you've learned a lot already from understanding how we deploy the private cloud infrastructure, how we optimize it for the private cloud, how we look at service delivery and automation, and we're back again with Adam to discuss application management, how we really monitor and operate these apps to maintain them, keep them highly available, and always running throughout our infrastructure. Adam, why don't you introduce yourself again?
Sure. So my name is Adam Hall. I am a product marketing manager in the Windows Server and System Center team, Windows Server and management team. I'm responsible for the application management scenarios and solutions across our private clouds and also the connection out to Windows Azure with the public cloud as well.
Great. Well, as we mentioned, we are wrapping up the course here, so please, here's a great opportunity for you to ask your questions. Let us know what you're thinking, and let us know all of these application questions. Many of you out there are infrastructure guys, but you really need to be able to optimize that infrastructure, maintain these best practices to make sure that your end users, your application developers are happy. So we're really going to focus on what are the methods to keep them happy, to keep their services online and running continually. So tell us a little more about what we're going to cover in this module.
Sure. So in this session, we're really going to cover, as Simon was saying, how do you meet your service level agreements? How do you meet that optimal performance of your applications? Once you have running your private cloud, once you've configured your applications, you've deployed them out, and then they've been running for a little while, how do you know that the end users are getting that experience that they require? How do you know that the applications are performing to the levels that you've agreed to as part of your delivery? So we're going to take a look at how we monitor those applications within the private cloud and outside the private cloud indeed as well. We're going to look at the deep insight into applications and how we can see down into the performance of the application at a very granular level. And then we're going to take a look at how we do proactive monitoring and reporting and how we raise the visibility of what's going on within the applications and bubble that up to the service level agreements, the dashboarding, and that deep insight as well. So just to recap, and for those of you that watched the previous session yesterday as well, when we talk about applications in a private cloud, we're looking at 4 things. We're looking at abstraction, we're looking at consistency, and we covered those 2 things yesterday. Insight, we took a quick look at the deep insight. I'm going to cover a little bit more of that today, and then the control. So we're going to really focus today on the insight into the applications, the performance monitoring, and how we bring out that visibility in the dashboards. So our first topic is monitoring those traditional and public and private cloud applications, and each of those is slightly different. When you look at a traditional application that is an application that is installed directly onto an operating system, you can monitor that from the operating system point of view, the infrastructure point of view, and through the management pack structure. When we move to a private cloud and we're running abstracted applications that are inside a service template model, then that's a slightly different model again. And then a public cloud application running in something like a Windows Azure Platform as a Service model, then that has a slightly different scalability and monitoring solution as well. And we bring those all together into a single management and monitoring toolset. So the different models that we have inside a private cloud. Let's start with traditional. This is an application that's running directly on top of an operating system, and we provide the capability within System Center 2012 to run these applications. You can run virtual machines inside our private cloud, you can deploy them out, you can manage them with Virtual Machine Manager, and you can deploy applications directly onto there. You could do this in a single tier service template, or you could also do that using tools such as Configuration Manager or Orchestrator to deploy those applications and configure them as well. When we move into a consistency model, this is where we're talking about Server 8V, where we're starting to bring the application together, in a service template I should say. When we bring those applications into a consistency model where we define the tiers of the application, how it's configured, we can dynamically inject those applications. If you are running a traditional application in a service template, then there will be some scripting, possibly some automation, and possibly Configuration Manager coming into play to really fill out that as well. And then we move into the abstracted model, which is Server 8V. This is where we encapsulate the application directly into a bubble, and we can drop that down. We're abstracting the application away from the operating system, enabling us to just drop a single file down onto an operating system, explode that open, and that is our application that's running. Dynamically registers with with the Service Control Manager through services, puts a virtual registry, virtual file system, and so forth. So we bring that together. And this really allows us to unleash the full potential of the private cloud. We have the updating mechanisms. I believe Ken covered those in the infrastructure session this morning. The way we can dynamically update that, the ability to have the same application deployed the exact same way every single time because it's been parameterized and encapsulated inside that service template. Scalability and elasticity come in here as well, where when you scale an application out and it's running in server app V, then so long as the application is aware of that fact that it's been scaled and it's elastic, then we can bring that together and scale that out on demand based on performance load or ahead of time in a manual fashion as well. When we look at managing applications across multiple clouds, and this is where we're looking at applications running in service templates on our private cloud, and they can be running on top of Hyper-V, VMware ESX, and Xen Server through the Virtual Machine Manager template. And then we have the Windows Azure platform where we have a package and configuration construct. These are different applications. It's not the same application running in each place, but we can manage and monitor them in a consistent and in the same way. That's from a deployment point of view, from a monitoring point of view, and a management point of view as well. When we bring that together, it allows us to get a single view across our applications that are running in Windows Azure, across our applications that are running in the private cloud, and we can bring those together into the single pane of glass. We can see what's running, we can see what's going on, and from a monitoring point of view, we can see the performance and health of those applications in a consistent way as well. So just a little bit about how we manage the Windows Azure subscriptions. And the management of Windows Azure in the public cloud is a core tenet of our private cloud. One of the things that our customers are talking to us about is when you have capacity constraints on premise, or it doesn't make sense to run it on premise, or you need some extreme scalability, then something like Windows Azure allows you to do that. You could put a component of an application up in Windows Azure, you could run your entire application up in Windows Azure, and that ability that we have to manage every application or any application across every cloud really allows us to be very competitive in the marketplace. The way that we do the Windows Azure subscriptions is we connect to these from a deployment and configuration point of view with App Controller. App Controller stores a private key in the App Controller database, and that talks through the Windows Azure Service API using API authentication and those keys. The public keys are loaded into each subscription, and then what we can do is manage each of those subscriptions in a common way. We can see multiple subscriptions, and then we can delegate down how those applications are running. We can see each application can be delegated down to a number of users or Active Directory groups, and it means that you can really manage these applications in a very consistent way. Those delegations can be read-write and read-only as well. Now that's how we manage from App Controller at a configuration and deployment point of view, but that's also the same mechanism is used when we connect Operations Manager to monitor those applications in Windows Azure. All you have to do is load that same private key that's in App Controller, you load that into Operations Manager, and that same mechanism of managing the application becomes available. So we're going to jump out into a demo now and take a look at how we manage our applications across those clouds.
And so what are the different components that you're going to show us in this demo?
We're going to take a look at App Controller in this demo. I'm sorry. My connection to my remote has just dropped, so I'll just reconnect that back in one moment. So what I'm going to show you is as we go into App Controller, we're going to take a look at how we get a single view across those multiple Windows Azure subscriptions. We're going to take a look at how we can deploy applications into both Windows Azure and our private cloud, and just see how we get that consistency model across both as this just logs back in. Okay, come on. All right, it's taking a little bit of time. Here we go. Okay, we're back in. As that logs me in. Okay, sorry about that. We'll just bring up App Controller. Okay, so just a quick recap on this is App Controller. This allows us to get that visibility across both sets of applications. Our private clouds, we can see on the left-hand side here. We can see our quota availability. We can see how many virtual machines and processor and those resource capacity that we have. We can see in the middle here we have our 3 Windows Azure subscriptions, and we're going to take a look at that. And then we have a summary of all of the things that we have running. If we take down to the services page, and this is where we get to see the services that we have running across our various clouds. Excuse me. Just as that loads. Okay. So we've got our Windows Azure, and now we see our private cloud. So we have a single pane of glass. We can see applications that are running both in Virtual Machine Manager private clouds and out to Windows Azure as well. We have a couple of different views. You can get a lot of detail. If I switch that view, I can get a very detailed look at exactly what's running. I can see what status the application is in terms of whether it's running. We can see which environment it's running in terms of pre-production staging, or whether it's the production environment, and see things like the release that's running. So one of the tags that you see up in the top side here is the pending servicing tag. And what that means, Kenan showed you how we do updating of service templates and delegate that out, and we can do that deployment as IT back in Virtual Machine Manager, but we can also do this in App Controller in a delegated model as well. And if we take a look at the menu within App Controller, we see we have an option here to upgrade. And when we upgrade, what that's going to do is to tell us that we are currently on release 1.3, and we have a new release of 1.4 that is available. If we hit that upgrade button, it's going to go through and recompose that application and perform the updates that have been made available to us. Okay, we won't complete that right now. The other thing I'll show you is if we take a look at the diagram view of App Controller, we can see the structure of the application. Now, you've got scalability and elasticity within the service template model. And from within App Controller in a delegated fashion, we can scale out our application and the tiers of the application there. Now, scale is an interesting one in terms of you could do it in a dynamic fashion based on load. So we can have Operations Manager monitoring the load that's on our application, take a look at how the load that's coming on, and based on the thresholds that we have, we can scale out the application. Or if it's more like a manual scale out because you've got a known event coming, you might want to delegate that down. And so by simply clicking the scale out button, it's going to say, are you sure? We can say yes. And that's now going to trigger off, and this will take a little bit of time, so we'll see this progress as we go through the presentation today. This is now scaling out that tier of the application. Now, scale is slightly different in a Virtual Machine Manager private cloud than it is in Windows Azure. Windows Azure is a fabric scale-out. Having some challenges with my demo environment. Windows Azure is a fabric level scale-out, and it is allowing you to scale the fabric level. When we scale on premises, we are scaling out at an instance level. So what that was doing was scaling out the application at the instance level, and I would have put a new Virtual Machine Manager out, a virtual machine out into Virtual Machine Manager. If we take a look at a Windows Azure application that we have here and take a look at the diagram view of a Windows Azure application, it looks slightly different, but the same construct applies. Instead of we have a hosted service name instead of our application name, and a slightly different set of information. We have things like the public URL that applies up in Windows Azure to our application. We have where geographically located within Windows Azure that we are running, and any certificates if we had them configured for the authentication against our application as well. At the deployment level, you get to choose which operating system we're running in up in Windows Azure, and whether this is a production or a pre-production staging version of our application. Scale occurs in a very similar way. If we take a look at the properties of a Windows Azure application, we have 3 instances here. We can change that down to 1 and click Update, and that's now going to do a Windows Azure scale down. And it's going to tear down some of those instances and scale it back to 1 over time, and that tile will update as it is scaled back. Again, this is something that I've done manually, but we could also do this through Operations Manager, where we trigger an automation based on the load that's coming back against our application. Covered this briefly in the previous topic, but just to recap also the ability that we have across both public and private clouds to manage the underlying resources that are in our applications, and the ability we have to create containers and storage up in Windows Azure and deploy out there, and also across our private clouds the ability to replicate between dev and test and prod in a copy-paste scenario with our templates, and manage those underlying files in terms of uploads from an application developer who's given us an update. So that's just a quick look on how we manage the application across our public and our private clouds.
So with that diagram view that you had, what did you create that in? Like what tool, what utility was that?
Okay. So the diagram view that we're seeing here in App Controller is a representation of the service template that is created and managed within Virtual Machine Manager.
Okay.
So Virtual Machine Manager creates service templates. That is where the editor is, and that is where all the management of the service template is there. When you deploy an application, this is a visual representation of that service template.
Great. We have another question here.
Sure.
So with this with App Controller, this app deployment tool that you're showing, would this be considered PaaS or IaaS, platform as a service or infrastructure as a service? So perhaps could you just define those two definitions for us as well?
So platform as a service is what Windows Azure is today. And that is Windows Azure. It is a platform that you can develop against. It has a very basic worker role where you can run a virtual machine up, but it is stateless. And so as we look ahead, there'll be enhancements to Windows Azure over time. But today we're looking at it as a platform as a service. And so what we're connecting to here is the platform as a service. The applications, if we go to, say, deploy a new version of a Windows Azure application and take a look at the cloud, if we choose our development cloud, our Windows Azure subscription, and we're configuring this hosted service, it's going to prompt me for, if I just quickly give this a name, let's pick up the satisfaction survey would be fine. When we configure the deployment, let's just give this a demo app. We'll put it into staging, which is fine. It's a development. What it's going to ask us for, instead of asking for which service template do I want to deploy, it's going to ask me for which package and configuration, and that's the platform. All of the operating system, all of that underlying resource is taken care of for you, and your application is simply running on the top of that platform. You don't need to interact with the underlying operating systems. You simply browse for the applications that you want. You choose. We can do our we'll do the satisfaction survey. Seeing as we're deploying that one, we connect in and have the associated configuration file that goes with that. This is talking out to Windows Azure Live. And once we've done that, we can figure how many roles we want. By default, it's running three roles within Windows Azure. And if we hit deploy, that is now going to go talk to the Windows Azure Service API, connect through to the platform as a service, and deploy this application out on top of that.
Great.
Okay. So application maintenance, and I know Kenan covered this in an earlier topic, but I'll just cover it from an application management point of view. Moving to image-based updating of applications is quite a big shift. We're moving to virtualized applications, we're moving to a different way of packaging the application, and then a very different way of being able to update those applications. The application, because it's in a virtual bubble, we can simply unmount that bubble and replace a new one over the top of that, but we can also do image-based updating of the operating system. And the way that this works is when an update to an operating system is required and you're running server-at-v on top, it would do an export of that application and all the stateful information associated with that application, put the new template back down, bring it up, it runs a sysprep, joins the domain, does all those kinds of things, and then that application is imported back in top again. So the ability we have for have a tier with an application, scale out to 2, replace one, replace the other, and scale back down again. We had no downtime. We had full availability of the application whilst maintaining all of that stateful information about the application. Because it's template driven, we're driving consistency here. When you use a template, it's the same way every time. Think about a Word template and it's got some fields to fill in or a web form to fill in. You can't change all of the graphics and the words around the outside. You can only fill in the fields. Same thing happens with the template. It's tested, it's developed, it's run through all the dev processes and then rolled into production, and then when you deploy that and update that, it's very much going to be the same way every time. And that consistency brings a lot of value to the business. It's showing that when you do something, the same thing happens every time. It's taking away some of those human elements where people can make mistakes, and it's saying, you know, you can spend your time much better doing things that are of value to the business rather than clicking buttons and installing applications. And that's really adding a lot of value to the IT pro role. You can be developing these applications, you can be creating these service templates, you can be packaging in server-at-v. That is of far more value to a business than clicking next through a wizard and configuring an application. And then the delegation, and we talked about delegation with control, and that ability for IT to set up the constructs of delegation, allow application owners to operate within the boundaries that they've been delegated, but being able to retain the control and the consistency. IT is responsible for the service levels. They're responsible for ensuring that all the information is captured, that the CMDB is up to date, that regulatory compliance is maintained, and so forth. So that ability to retain control but delegate down to the application manager the ability to manage their applications. Excuse me. So I'll actually do one sort of slight demo change here, and I'll actually want to bring it up, and I'll quickly bring it up here. I'm going to bring up the server at V, because it's good to get a feel for how this actually works. And so server at V is a sequencer, and it's basically you start the sequencer, you run through and configure the application, and it captures everything that goes on. So server at V, basically you lay down a vanilla operating system that has nothing on it. You configure everything that you want. The service templates, if you recall, can do all the injections of roles and features, so you can have those pre-installed before you do the install. And then you can either create a new package, which we don't have quite time to package an application today, but what I'm going to do is open up an existing package and show you what the net result looks like at the end. And so I've got a few application packages that are running here. We'll pick up our order processor and we'll mount that up. So basically what you're going to see here is the net result after we've packaged an application. It's captured all of the virtual services. So these are the Windows services that were installed and mounted as part of that installation. As we lay this application down, this service will be registered with the Service Control Manager and then started. We write down the virtual file system. So in our application here, these are all the files that were installed as part of the application. And again, as we mount this virtual file system and it brings up all the files, they will be available to the operating system in the application as if they had been installed in real time. If we had any registry entries, they would be captured here. Any additional files that were put down. And then the properties around when it was captured and what goes on. And basically that's how an application works. You start the capture, you install it, puts it into the bubble, and then you can maintain that application as an entity rather than all the individual components that come through. So that's just a quick look at the Server at V sequencer. There's a lot of guidance on this coming through. There's a Server at V blog out there with lots of examples of sequencing applications. So if you want to give it a try, you can install the sequencer, run your application through, see how it pans out. We covered yesterday all the different pieces of the applications that we can capture, and then you can run it through the sequencer and pipe that out and get it into a service template. You can also deploy Server at V packages using Orchestrator and Configuration Manager as well. The service template construct just makes it a lot easier because it's graphically driven. Okay. So, we've got our applications out there, we're maintaining them, we've got updates coming through. Now how do we get the performance management out of these applications? How do we bring together and drill into what's really going on inside those applications when they're there? And pretty much we start this conversation with an end user who's saying, my application is running slow. How is my application running? And for me as an end user, it's running slow. Well, where's the problem? What's really going on? We talk to the network guys and they take a look at their diagrams, everything green, nothing's down, all the applications are available, the network is running, no problem. We talked to the developers. All the code passed the testing. There was no bugs in it as far as they were aware. All the test passes worked. And you talk to the infrastructure guys and they're like, servers are available, green across the board, high availability, awesome. But yet the end user is having a poor experience. The application is slow, they are having problems. And this really highlights the difference between availability monitoring and performance monitoring of applications. Server-side monitoring shows the application is functioning. It shows that the application is available. It is functionally a good application and it works. It's just that it's slow and it's having some client-side problems. So what application performance monitoring shows us is that even though the servers and the applications are available, there are internal problems or performance response issues that are going on. Application performance monitoring is all about pinpointing where the real problem is and reducing that mean time to resolution. You know what's going on, you can see the end user experience, you can see the actual lines of code that are executing as they're using the application, and then you can see what the response time's looking like, and you can drill down and cut through all of the finger pointing and basically go, that's where the problem is, now let's work on a resolution rather than arguing over whose responsibility is to fix it. And it's breaking down that barrier. So the deep insight into application performance monitoring. This comes from the Avicode acquisition that we made in 2010, so a couple of years ago now, and we've now embedded this functionality natively inside Operations Manager. So if you are running Avicode today, as you move to Operations Manager 2012, we remove the need for the additional infrastructure, we remove the need for multiple agents. One application, which is Operations Manager, and then we have a single agent that runs both Operations Manager and the application performance monitoring services as well. We collect all the data from the .NET calls, all the application methods, we cover the variables, the parameters, and all of that information that's going on at the back end. From the client side, we cover iOS.NET web applications with Operations Manager 2012. We will retrofit or provide updates to Operations Manager that bring the additional functionalities that exist in Avicode and beyond as we move forward over time as well. And with the web applications, we're really getting page load times and exceptions and JavaScript exceptions. We collect this data using JavaScript injection. So if you have an application, you can get performance monitoring information out at multiple levels. To get client-side information out, your web application needs to have some level of JavaScript in it in order for us to be able to get that information out with 2012. We get the code level execution level information, and this allows us to break down the line of code, where the time was spent, how that information breaks down, and be able to drill in and share that information. We give the rich visualization at the client side, so being able to see the end user transaction and where the time was spent as you were doing that. And being able to see, well, was it that it was network latency? Was it that it was server execution time? Is there an issue within some sort of peripheral, or is it some sort of DOM loading going on there? And really being able to pinpoint that. This information is available in a web application, which means that you can send a URL to your developer, to your application owner, to the IT pro. Everybody's seeing the same information, which is a critical part of working with applications. So how do we respond? If we've got an issue going on and we've got this breakdown to see what's going on, what we have here is we can very quickly see what the threshold is, so we know where we're supposed to be, and that's what we expect the end user to see. We expect the end user to have a response from the application for their transaction that completes at the threshold. We very quickly see what the impact to the user experience is. In the picture that you can see there, we're well over the threshold, something like 1.2 seconds when we're expecting a half a second response time. So we're well over, and now we can see what the actual impact to the user is. There is a very tight integration across System Center when it comes to alerting and incidents. And basically the way that this works is that when an alert is raised in Operations Manager, that alert can be forwarded to Service Manager to raise an incident. Once it's in the incident queue, now you're doing service levels against this, and Sean would have talked a lot about this. You can raise incidents to problems, you can do all sorts of analysis about when incidents are happening, automated remediation, so if something goes wrong, try the basic things. And I sort of think about this in terms of an on-call engineer, and when do you get someone out of bed? We've all, or most of us have probably been on-call engineers at some point in their lives. I did it for about 10 years. And this is where something goes wrong, it's 2 o'clock in the morning, what do you do about it? What are all the things you're going to do when you first wake up? You're going to check Windows services, you're going to check that TCP/IP connectivity is working, you're going to check that the website's actually running, start IIS, you're going to look at event logs, you're going to look for all these common things that are going on. And what we're trying to do with the automated remediation is to pick up that alert that got synchronized across to a Service Manager, run a bunch of automatic things that check all the basics. If that fixes it, great. We capture that knowledge, we close it out, and we now know that it's happening, and then we run a report to see if it happens over and over again. If it doesn't solve the problem, what we've then got, though, is an engineer getting out of bed where we can say, we've done the basics. It's good, it's covered. Now we need someone with some intelligence to go do something that the machine couldn't cover. It's not any of these things because we've already tried that. Go start on the hard stuff. All of that knowledge is shared between the developers, the network infrastructure guys, and we have a connector from Operations Manager across to Team Foundation Server, which is like the source code repository for Visual Studio, so that when an application issue is raised, that gets automatically synchronized across to TFS as a work item. Now the developer knows that there is a work item against their application because there's a problem. They can start working on debugging that, working out where the problem is, work on a fix, and get that back into the environment. As we resolve that issue and alert, what we've now got is knowledge capture, and we've got ITIL, and we've got all those great service management capabilities that Sean talked about, along with the automation. We've got that complete closed loop. We deployed the application, we're monitoring it, we see an issue, we raise it up, people become aware of that, we try to automatically resolve that. When it doesn't work, we escalate, and everybody's looking at the same piece of glass. Everybody knows what's going on, and that's a big shift. And if you think about the capabilities of a private cloud and being able to deliver to high service levels with automated remediations and all the self-service, everyone needs to be looking at the same picture. Everyone needs to know that everything's okay. And one team not talking to another can be solved by the sharing of that information. From a reporting and trending analysis point of view, the application advisor allows us to run a lot of reports and to see what's going on. These can be what's going wrong, where the performance issues are, and a lot of reports. And I'm going to show you this in a demo shortly. And it's gaining that quick visibility into the top issues. I think that is one of the most critical things from an application owner point of view. What are the top 5 things that are going on, both in terms of application issues as well as performance issues, and where should I be focusing my time? My role is to make sure that the application is performing to its service levels for the business, which is where end users are interacting with it, actually doing the work of running the business. My job is to make sure that I'm top of that, and what this information does is allows us to see that. We can very easily see where the focus of resources and understand all those relationships between the environments, between all the different components of the application. So just because one component of an application is performing poorly, what's the roll-on effect? What else is going to be impacted by what we're doing there? So let's go and take a look at what the Deep Application Insight and Diagnostics looks like in Systems Center 2012.
Now, we have a question here, regarding this application monitor. The first question is, what type of application development framework will run on a Microsoft private cloud? Is it restricted to just .NET? Secondly, to get the Deep Application Insight, is that only .NET, or, what exactly can we monitor there?
Sure, 2 very good questions, Simon. So, to answer the first question, you can run any application that will run on Windows in a private cloud.
PHP, Ruby on Rails, .NET,
Java, whatever. And to be honest, it's not even just Windows. The service template construct supports Windows, but if you're running just simple VMs, and you could be running Linux, we can deploy Linux with Hyper-V, we can manage that with Virtual Machine Manager, you could be running a Linux machine with PHP and Java on it and as an application. The Deep Insight is where the differentiation stops a little bit, where we can monitor anything that's running on that private cloud. We can monitor applications running on Linux and Unix and Solaris. We can monitor Java applications. The Deep Insight is for .NET only today. With Systems Center 2012, we have .NET web-based iOS applications. Those are the ones that we get this real deep code level execution, and we are actively looking at how we enhance that and taking customer feedback about what they want to do. This is a growing area of the private cloud. It's one of Gartner's top areas in terms of capability for managing a private cloud. So we have a lot of investment going on there, and continue to please give us our feedback on what you want to see there.
Excellent. So what exactly is the difference between APM and synthetic transactions?
Good question. So application performance monitoring, synthetic transactions are one of the things that come together to enable us to get the application performance monitoring information. So a synthetic transaction is a pre-recorded flight test through an application. So if I jump down to my demo environment here and take a look at the web transaction monitors, you can see that I've got a few synthetic transactions going on. If I take a look at the shopping cart one, what this is going to do is run through a series of requests against my web application. Excuse me. So you can see here that we have a number of website calls that have been made. We're loading up the base website just to warm that up. We're checking that we can get to the base page. We're doing a submit, an HTTP post of some information. We're simulating going through the checkout and simulating looking at the cart. So a synthetic transaction is all about running a flight path through an application and making sure that it's working. The deep insight, which I'm going to talk about in a minute, is based on there's a management pack for APM, and that allows us to see inside the application as to what actually happened inside the transaction. Synthetic runs a transaction, APM looks inside that transaction.
Okay. Now, what if we have older applications? You know, let's say an application that was built for IIS 6.0. Are we still able to use, you know, all of these monitoring with Operation Manager 2012, or might there still be a need for us to use an older version of Avicode?
Sure. So APM in System Center 2012 supports iOS 7 and above. If you want to get the deep insight into prior, then yes, Avicode from a retrospective historical point of view can still monitor those previous versions. But the base of 2012, the APM is based on iOS 7 and above. Okay. As far as monitoring goes, though, we can monitor those websites with Operations Manager 2012. It's just the deep insight has a limit of iOS 7 and above.
Great, thanks.
Okay. So if we take a look at how these are configured, and I'll just do a quick recap on where we got to with this. We configure application performance monitoring using the configuration here to turn APM on. We have the discovery mode. It shows us what our applications are. When you deploy the iOS APM management pack, it basically adds that management pack into the environment. It will do a discovery process across all of the operating systems that you are monitoring and managing. It will then provide you with a list of all of the applications that can have APM turned on. Now, these are not necessarily all having all components of APM. Some of them might only give the server side out. Some might give server side and client side. But these are the applications for which APM will at least function and will give back some information. You simply choose the applications that you want to monitor, click on them, click Add, adds them in, and that turns that on. You then just configure the defaults, and the thresholds are where the application performance monitoring SLAs come from. So when I say 500 milliseconds here, if a transaction takes longer than 500 milliseconds, we're going to get an alert to say we've got a performance problem. We didn't meet our SLA. This is the one piece of information that we can't provide for you. Only you know what your applications run like. Only you know how fast they can actually run and what that appropriate threshold is.
So there's another great question to know about what are the different reasons why you might go and use application performance monitoring. So for example, would a good scenario be using it for load testing, seeing how much this actual application can handle as far as, you know, client connection, CPU utilization, storage I/O, things like that?
Sure, and it can be a load test kind of scenario, or it can be a real world. So absolutely, if you want to stand an application up and set a threshold, if you keep pounding it and keep turning the load up, at some point in time you're going to hit the threshold where your application or your infrastructure can't respond to the transactions fast enough, and then you'll know where your breakpoint is. And APM is a good way of seeing where that breakpoint is, because that threshold is going to, at some point in time, as you put more load into it, you're going to trip over it. And so therefore you'll be able to do some scaling in terms of, based on this configuration, we managed to get 1,000 users before we started getting alerts. Now let's turn the threshold down and see what we can get. And as you give it more capacity, you can raise or lower that threshold, and you'll start to get a sort of a formula come together of this much capacity with this many users gives me this much response time, and you'll be able to do that calculation and see how that's going through.
So great for not only production but also for testing as well.
Absolutely, yeah. Yeah, and it's one of the places where people say, where should we start with a lot of this stuff, right? Literally, and do this in development and testing first, please. Don't put it straight into production, because you might get flooded with alerts. But you know, turn this on and point it at your applications and start to see what you get coming back. Once you've configured that performance monitor for APM, what you then get is, excuse me, I'll just widen this out a little bit. It creates a folder structure, and the folder structure, and it does this all for you. It creates for each monitor that's there, it will create an active alerts, a summary dashboard, and folders depending on what it can do. So the Dinner Now application has a back-end service, it has the client side, and it has the back-end application as well. These are built for you out of the box. These will be created as you do it. So you can see we've got a number of alerts coming through. If you turn client side on and you get no alerts, there's two possible reasons for that. One, the first time you configure APM, there is a requirement to restart IIS and recycle the application pools. Very first step, go and do that. Restart the IIS, do a reset on IIS, and do a recycle on the application pools. You will have alerts in Operations Manager for those, but do that first. If after doing that, and you've run through the application, you've launched it all, you've gone through and you've used the app, and you still get 0 alerts back, it's either that your application is performing well enough that it's not going to meet thresholds, or it means that your application can't give that information back from a client-side alert. Simple way to tell, set that threshold to 1 millisecond and then run through the application, because you're going to break that. If you still get no alerts back, you have an application that won't give client-side information back. For each of those components that we talked about, you get some dashboards. So if I take a look at the Dinner Now service, where you get a default dashboard for the component health, which is going to say, how are these running? I have 2 iterations or 2 instantiations of this application running, one on OMO1 and one on DCO1, and you can see that the one on DCO1 is okay, but the instance that's running on OMO1 is not quite so healthy. Down the bottom, you see the alerts that are coming through. And this alert is a standard Operations Manager alert. You can see it gives us information about the alert description. And down the bottom, you get a URL that will launch the APM Diagnostics console. And if we launch that, we jump across to our website where it's going to take you to, and I'll just bring this up to show you what that looks like. It's going to take us to all of those details about what's going on. You can click the link from Operations Manager. I'll just cut across now and start moving into there. So I'll bring up the Diagnostics console and I'll bring up the Application Advisor, which just take a couple of seconds to load. So the diagnostics this is the detail behind that alert. If I look at Operations Manager, you can see there was a lot of information in there. There's an application failure, here's the exception type that came through, the communication, it kind of tried, it gave up, it aborted, and then it threw all sorts of interesting handle exceptions, and all of that information will be raised into the alert. So in the Diagnostics console, you're going to get information like this coming through as that loads up, there we go, where you can drill in and start to see, for that transaction, where was the time spent, what type of web part were we actually dealing with, what was the code, what were all the variables that were submitted, what was the URL, what was the endpoint address, all of this rich information about being able to see what's going on. You can also see down the bottom some of the capacity information that's there. So you can see that we had a threshold of 500 milliseconds. We're running with 4 CPU cores in the server, so we can get a bit of information, and some process IDs and thread IDs as well. So if you get into that sort of deep Mark Rusinovich kind of style troubleshooting, and you're bringing up all the sysinternal tools and the winternal tools and those kinds of things, this is the information that's going to allow you to really start drilling in. And this is about trying to solve where the problem lies. You now know there's an application problem. You know about the infrastructure monitoring underneath. You know about the code coming through, and you can get a feel for where that information is coming from. You get a list of any similar events. So if the same thing is happening in different locations, you can get a summary, and you can see, wow, the same kind of event is happening across multiple versions of my app from multiple users in multiple locations. It's probably indicative that there's actually an application issue inside, as opposed to it's just an instance where one version of the app's not running so well, so maybe it's just a problem with that particular server. As soon as you start to see that it's happening across different instances of the app, then you're kind of thinking that it's a problem inside the application itself. Related events are all the things that happen at a similar time, so you can select a time period and say, well, within 1, 2, 3, 5, half an hour or an hour, what else went on that was kind of similar there. So if I break that out to an hour, you can see, wow, a whole lot of these things happened at the same time within that hour, or you can just check and see, well, what happened just now? So within the last minute, we've got that information. The distributed chains is where we get to see the relationships between the different components. So you can see here that the issue was raised with the search.aspx page, but there were other things that were associated with that. We have the client side, so we can now see that, well, this was a back-end server issue that was raised, but the client side, we can drill into that, and then the output from that page was that it was trying to do a lookup on the restaurant categories and the menu types, and we can see a breakdown of what were the inputs that came into this issue and what was the roll-on effect of where that were. And as we click on each one of those, we can drill in. Is it going to drill in for me? No, it's not. We can also pull back the performance counters as well. So if we're tracking perf counters for particular things, we can select the ones that we want to see. It's going to add it to the graph and add that in. So, we can very quickly see for that particular infrastructure in the application, we're starting to see all the different perfmon counters that are coming through. We can see, well, if it's a network problem, what happens when we add those interfaces in, and you're building out a very much a perfmon counter kind of graph, but it's all about troubleshooting, saying, well, this is the error coming through, but what's the root cause? We now know the line of code that's coming through. We've got all the perfmon counters to back up what the impact is, and we can feed that information across to our developers. You also have, in the Actions menu, the ability to copy the link to that, and if you copy that, it's going to get a nice long URL that links directly to the information that I'm seeing. So if I need to talk to a developer and say, hey, this issue is occurring and here's the details, I can just send that person a link, or you can do an export if you want to take that out to a file, and it'll create an HTML file for you, a compiled HTML file with all this information in it, and then you can ship that around as an attachment or store it as well. Seeing how all of these things roll together is where the App Advisor comes in, and this allows us to do a lot of rich reporting across all our applications. So we have a number of built-in reports that are available to run. Excuse me. You can see that we've got some failure analysis and performance analysis, and so we'll take a look at what's going on here and see a few of these. You can run very detailed reports, like on client side. You can run a breakdown of just seeing AJAX calls that are made, or you want to see the client latency issues that are going on, and you can get very, very detailed. We can do a summary performance analysis just on the client side, or you can get an all-up report that sort of covers everything. I'll show you what a couple of these look like. So we'll roll this back a little bit. Okay, and that's going to build a report out for us. This is part of the Avicode acquisition. So Avicode had a lot of this rich reporting. We've now built it into Operations Manager and made it available. So here's an example of a report. You can see we've only got one source, we've only got one application running here, so that's fine. And we can get a breakdown of what's going on. So for the Dinner Now client, we can see that for the default.axpx page, so this is the home page of the application, we've got a number of events coming through, and we can see where the time has been spent in terms of network, server, DOM, peripheral loading, all those kinds of things coming through. And there's lots of guidance about what all that stuff actually is. And then we can look at the JavaScript and AJAX calls and see where the time has been spent there as well. So it's really about very quickly being able to see what are the big issues, where is the time being spent, and in this particular report we're seeing what are the client-side issues that are coming through. We can also see failure analysis coming through as well. So if we want to run a report for our failure analysis, and we'll just go back and get some real data, and run that report, it would help if I configured new source. Oh, it wants to know where I want to run it for. Alright, the resolution that we're running at for this demonstration is rather small, so I'm kind of crunched, so I'll skip that one. We're running at a very small resolution for the recording, but we'll move on to one of the other performance reports. That's going to run. Okay. The summary failure analysis is another favorite of mine. So now we're going to see where are the real problems inside the application. We can see across our application, if we scroll down to the top 5, we have a number of exceptions coming through, and you can see a vast majority, 98% of our issues are with this one particular exception that's coming through. So it's probably a good indicator that that's where I should spend my time. It's going to bring up a window again, linking together all of those different incidents, or all the different issues that have happened, all the different times, and again I can drill into it and see all of that information. This one is a format exception. You can see it's a .NET framework call that's been made. We can see the parameters or any variables that have been run, as well as the source itself. And if we take a look inside the code, got to have diagnostics installed. We can see down into what's going on there. We can see when it's called, and now we have a lot of detail here. It's a very developer view of the world, but from an application owner point of view, I can have an intelligent conversation with my application owner now and see how that's going on and what's running. Again, similar events, you can see all the common things that are going on, things that are related, again, being able to apply different variations there. The distributed chains, this is a very specific instance of one version, so there's no multi-transaction involved here. And again, the performance monitor counters coming through and being able to see what's going on at the time. So it's just a quick look through the diagnostics that are available, turning it on as wizard driven, and being able to get that insight very quickly.
Great. Now, with APM specifically, can we monitor SQL Server transactions? Do you know about that?
Okay, so SQL, there's two sides to SQL. There is, if you're monitoring SQL itself, then we have a very rich management pack for SQL, which is going to take a look at what is running within SQL as an application itself. Then we have applications that are making calls to SQL. APM gives us the information and the breakdown about the calls that are made to SQL. And in fact, if I scroll down a little bit here, let me find a. Actually, let's go over. No, let's go home. We can take a look. There's some SQL instances. Let me see if I can find. And typically I can't find one right there. So basically, actually, if I go into here, we'll be able to find it. We can drill down and see the SQL query that's run. Okay, so it's not going to tell me either. So within the application, within the transaction, if it makes a SQL call, then it will be able to see what that SQL transaction was, and you see the SQL query that was run. Sorry, I couldn't just find one right then.
Oh, no worries. So, you know, in general, sometimes you can get management packs that are noisy, right? Mm-hmm. You know, too many alerts. What are the options that we have as far as, you know, creating an override for a default management pack? You know, saying, here's the different alert levels. Mm-hmm. I want to ignore the informational alerts. Like, how granular can we get? How can we manage that?
Good question. So if we take a look at the health status of a machine, for example, and take a look at the alerts that are coming through. Let's pick one. Have I got one that's unhealthy? Look at that. I've got no machines that are unhealthy.
This is a Microsoft private cloud. Everything's working.
If we can take, I need to find an alert. Let me take. Probably not going to have. I need to find one. Let me just find an alert. The answer is that yes, you can. You can override. And unfortunately, everything's way too healthy in my environment. Here we go. All right.
That's a good problem to have.
Let's just take an alert that's come through for a server. Okay. So we've got the ability here to set an override. Okay. So if I'm getting an alert coming through and it's really noisy, really chatty, and I'm getting this alert or not, as you open the Health Explorer, you have this option up the top that says overrides, and that basically means you can disable the monitors completely. Just turn it off. You can turn it off for a specific class, so just turn it off for virtual machines, not physical. You can turn it off for specific objects, specific machines. So at all those different levels, you can turn it off if it's too noisy. If that's really something that you don't want to know about, you can turn it off at a very granular level.
Great. Now, as we talk about, exploring these reports and getting the information, what are the different options for viewing them? Can we view and run Ops Manager reports from any type of web console, or do we need full access to, like, the Operations Manager console to be able to interact with it? Could we publish to SharePoint, for example?
Okay. So, let's just take a look. I do have the Operations Manager console here. Let's pray that everything's all good. We had a couple of quirks today, so let's just hope this throws out. So Operations Manager 2012 provides a very rich Silverlight web console. And the Silverlight web console enables us to see basically the same information in Operations Manager, the console, as we can in the web console as well. It is a delegated console and it allows us to see pretty much what we're allowed to see from a delegation point of view. Yeah, I'm going to get a couple of errors here, I think. There's something strange going on. I apologize to the demo gods out there. Something's not quite right in my environment. But just to show you what's there, you can see now I'm browsing through the Operations Manager web console. You can see that I can drill down. I can see all of that same information, drilling down into .NET monitoring, the Dinner Now website. It's the same hierarchy that I was looking at inside my application, inside the Operations Manager full console, and I can even see those same dashboards as well. So taking my life into my own hands and clicking on this, hopefully we're all okay. Yeah. I think I've got a Silverlight issue actually on the laptop that I'm using here. But basically, you can see here I created this dashboard yesterday, and I populated it just with one widget. If I jump across, it's going to come up each time. I do apologise. What we can see here is all of that same information that we could see in the full console is also available to us here in the web console. And this allows, as an application owner and as people that are not part of IT, I mean, non-IT people don't really have an interest in bringing the Operations Manager console up, and even if they did, they probably wouldn't be allowed to, right? So you can delegate down, you can create a group, and in fact, I'm going to show you how to delegate out a dashboard in a minute as well. You can create a group, add a user into it, and drill it all the way down to a specific user can see a specific dashboard and nothing else. So it's very delegated and very concise there.
Great. Another question back to APM. So will APM only work for web-based applications, or can it work on, applications that run on traditional metal, inbox, in-house applications?
Okay, so with System Center 2012 Operations Manager, the APM management pack works with iOS, .NET web applications only. Okay. AviCode does a lot more than that, and as we do some updates, as I mentioned earlier, we will do some updates that bring in the additional AviCode acquisition capabilities, things like being able to do Windows services and Windows applications and so forth. You will still get a lot of information out of applications like SharePoint and Exchange. So you will get a lot of information out. It's just not the full deep insight that we have enabled for web applications in the 2012 release. But we absolutely have a commitment and a roadmap to enhance that over time and bring all of the AviCode acquisition capabilities in.
Great.
All right, let's jump back because we've got a good segue here into the dashboards and that visibility. So the next topic we're going to cover is that reporting and dashboarding and how that comes together. So application dashboards in Operations Manager are very, very rich, and I'll show you how we create those. We've got pre-configured ones. I showed you some of the ones that are out of the box when you turn APM on. We've got standard network dashboards and health dashboards as well. But then we have wizard-driven ones to create new dashboards, and it kind of is a wizard-driven. You select your layout you want, and then you start populating that with the information that you want to see, and then you can do publishing. And you can publish to both the web console, which is the delegation model, and then you can publish out to SharePoint as well. There is a SharePoint web part that actually talks to the Operations Manager web service. We're also going to be adding product dashboards into the System Center catalog. So as those of you who know Operations Manager today know, you can import management packs through the catalog. You will also see dashboards populated in here as well. And these are dashboards from the product groups that are really built to show you how to get that rich information about, and there's things like Exchange and SQL and SharePoint, and there's a number of product groups that are building these dashboards, and they will publish them through that catalog just like they do the management packs today as well. Gives you a very quick start, gives you quick insight, and if you're building these dashboards, it might well give you some ideas on the best things to look at and that information that you're looking for to know that your applications are okay. The visibility, and this is the dashboard that I just kind of brought, back one. The dashboard that I brought up, building out this kind of dashboard is very easy. It's wizard driven, and I'll do a demo on how we pull that together. But it's really about creating quick visibility into those applications and giving that insight really, really quickly to know what's going on. Okay. As far as that visibility, and we touched on this just in the question that came up, the ability to see the same information as an administrator in the console, which is the sort of an IT world, then being able to delegate that out through the Operations Manager web client and see what's going on there, and then also being able to publish that information out to SharePoint using web paths and pulling that information through. It's the same information across all of those three different methods of seeing that information, but it's pulling together all the different constructs from consoles to web consoles to SharePoint.
You just mentioned KPI. Could you just clarify what exactly the KPI is?
A KPI is a key performance indicator. So that is basically, it's a threshold. So when you see a nice sort of green, orange, red light on a dashboard, there is a KPI behind that that defines when is the light green, when is the light orange, and when is the light red. And basically the KPI lists what those thresholds are. So if it's above this number, it's green. If it's between this number and this number, it's orange. And if it's below that number, it's red. It's basically, it's really the metrics behind how that is. And typically those are number driven, but they can also be more subjective than that as well.
Great.
Now, where this information comes from, the management console, the operations manager console, is a WPF application, and it talks directly to the management server. The web server provides access to the web console and also to SharePoint as well. So that information is published through the web server, not through the management service. Windows Azure, and I'm going to touch on this a little bit as well, part of the private cloud has been able to manage out to the public cloud, and so our ability to know how our Windows Azure applications that we deployed earlier are available. So again, this does have a prerequisite, and I should cover this, that when you create a Windows Azure application, you need to enable the diagnostics module. You need to turn that on, you need to configure it so that it will give this information up. By default, it is not enabled, and if you point Operations Manager at that, you will get absolutely nothing back. Okay, so if you haven't loaded the diagnostics module into your application and configure it to give this information up, then you get nothing back. Basically, the way it works is that once you turn the diagnostics module on, it writes out to table storage, and it writes out all the performance data, the events, and the logs that are coming through. Operations Manager, using the private key, public key, read that information through the Windows Azure Service API, and get that information down, pull it back into Operations Manager, and enables us to give a view across both. So we can build a diagram that shows how the Windows Azure part is working as well as the on-premise application is running as well. And I'm going to show you how to do this in a demo as well. This part's on-premise, this part's in Windows Azure, but we have a diagram that scales across both. So with that, we're going to bust out and spend the rest of the time in the demo environment here. So going back to Operations Manager, and let's move across to our distributed applications. So let's start by taking a look at how we do Windows Azure, and then we'll close out with some topics around the dashboard and so forth. So these are our applications. You can see we have the Windows Azure deployment. We are just monitoring one of our Windows Azure applications, and we have a customer demographics app running up in Windows Azure, and a customer demographics app running on-premise. These diagrams, this diagram is dynamically built by, if I click the right button, I don't want to put it into maintenance mode. This allows us to see how it's built. This diagram is dynamically built by the Windows Azure Management Pack. It talks to the application, it gets all that information, it builds out the structure of the application, shows me the roles that's running, and if I drill down into this, then we can see the instances that are running, and that's as far as you can go down with Windows Azure. So you can get the health status of all of those application roles and instances that are running. When we look at the on-premises version of our application that's running, this is coming across from Virtual Machine Manager. And so the connector between Virtual Machine Manager and Operations Manager builds this diagram out, and it actually populates this diagram as the service deploys. There's quite a cool demo if you want to excite people and show them what's going on with the connector. As you deploy a service, have this diagram view up and refresh it, and it will show the diagram being built over time. This allows us to drill in and see a lot of information about what's going on inside the application. We see the tiers of the application, we see the virtual machines that are underneath that, and then we see the networking information. You can see the MAC address of the network card there, the operating system that's running, and all the information about what its name is and so forth, and also the VHD that's associated with that. And so there we've got an application running on-premise and an application running up in Windows Azure. Now, the way that we create these diagrams is in the authoring tool. We have distributed applications, and this is where we can create distributed applications. So we'll actually create now, as part of the demo. I'll show you how you build this out and how you can bring these together. So if we do this as a combined application, we will just start with blank, create a management pack. We'll just use the Windows Azure Management Pack for that. Okay, so with that, we are bringing that in. We're going to add a component and build out a diagram view. So we'll call this combined, and we'll have all objects available. Okay. So we're creating the construct here. So what we're going to do is allow this to populate. This is going to go through. It's going to talk to the Operations Manager database, and it's going to pull back all of the different objects that are available for us to do. You can see, we can see those services that are running. So we're going to do a very simple diagram here, and we're going to take the Contoso Customer Demographics app, and we're going to take the on-premise one as well. Very, very simple. That's all we're going to do, pull those two together so that we can drill into them. If we save that, then what we'll be able to do once we've saved that change is be able to take a look at what that looks like. So very simple diagram, but what you'll see is we can now drill in and see the combined status across both Windows Azure and our private cloud application that's running in a service template. It'll take just a sec to save. It's taking all of those objects, putting them into a construct, and now we can see it. So let's take a look at the diagram view of what that looks like as it builds out. Here it comes. Okay, so we created that combined construct at the top, nice, simple, and then we dragged in our two different components. We can now get a view across both of our applications. I can drill all the way down and just keep scrolling it down a little bit and see how far down we can go. And then I'll zoom it out a little bit so that everyone can see it. So there we created, very quickly, created a distributed application, dragged and dropped the two applications that are there, and now we see the sum total of the both sides of the application and how they're running across both Windows Azure and our private cloud as well. So that's just a little look at distributed applications and how we bring that together.
Do you have a question here?
Yeah.
So, is there any type of automatic discovery for applications, and any type of way that we can proactively discover and then monitor these applications?
So yes, absolutely. So, for example, when you deploy the Operations Manager agent, it will catalog the machine, get some basic information about it, operating system, and so forth. As you load a management pack, it will then scan those machines looking for those characteristics. So if you have agents on 10 machines and 2 of them are SQL servers, and then you load the SQL Server management pack, what that's going to do, is then go out to those 10 machines and say, hey, I know about SQL, who's got SQL? When it discovers SQL, it will interrogate it and pull back all of that information. So I've got the SQL Server management pack loaded. If I scroll down a little bit and take a look at the Microsoft SQL Server, what you'll see is that I didn't load in here and tell Operations Manager that these are my SQL servers. I pushed the agent to those machines and it discovered SQL when I mounted the management pack in. And so Operations Manager, if it knows about the machine and you load a management pack, it will then ask that machine, have you got one of these? And then it will pull in all the information. So you can pull back what all the database states are. So across all those SQL servers, here are all of the databases that are running. So I've got lots of databases across lots of different servers. It cataloged all those as part of the management pack. So that's very much an automatic discovery. And the whole point of Operations Manager is do the network discovery, connect to Active Directory and pull all these accounts back, get the agents out there, load the management packs in for the applications and hardware, infrastructure, operating systems you've got, and it will build all this information to you. And when it's connected to Service Manager, it will also pull all that information in as configuration items as part of the CMDB as well.
Great.
And so pulling together all of that information is how we build the CMDB in Service Manager. So from a dashboarding point of view, was create a top-level dashboard here. We're talking about application monitoring. If we wanted to create a new dashboard, we literally create a new dashboard view. That's kind of how hard it is to start this process. We have column layouts, some grid layouts. We can do service-level dashboards. We can do summary dashboards about applications as well. So we'll just do. We did a grid one yesterday. We can do a column one today. Actually, we can do a summary dashboard. That's kind of interesting as well. So demo dashboard, and we create that. Literally, it's then going to pick that template up. It's going to create a blank one. It's kind of like going file new based on a Word template kind of thing, and it's going to pull back this application and find out what all that information is. It's going to pull the performance information back. We're under dinner now, so it's going to populate it with that information. Each of these widgets can also be customized. Okay, so we can configure each widget and give it a particular name. You can see we've got top N, so therefore you could change that to top 5. You could say which object and group it is that you want to pull back. And so again, it's going to catalog all of the different things that are available. We could pull back for our Dinner Now application. It's going to search, pull back all the objects that relate to Dinner Now. Should take a sec because I've got a fairly large Operations Manager database running here. Oh, there we go. So we could just load in the Dinner Now SQL database. We can say, do we want any performance counters with that? So let's pull in screw all that up. Total database free, that sounds good. For the last day, why not? 3 days. Top results, and finish that off. Literally, this is a point and click. What are the KPIs you want? What are the pieces of information you want? Build out your dashboards, get that visibility really, really quickly. You've got so much information available in the Operations Manager database that you just need to expose it. And we make it really, really easy with these different dashboards. The one that I created yesterday in the session, we created a five-piece grid, and we went through and added widgets. So we added the dinner now state, which showed we just selected all the servers. If we bring up a different widget, we can say, well, what kind of widget do we want? Do we want a details one? We can get the state widget, performance widget in terms of what's going on. So if we do a performance one, let's go with transactions. If I could spell, that would help. Again, what is the filter for what we want to use? This is going to get a little repetitive, but that is the whole point. That someone said to me at an event recently, wow, that's just kind of repetitive, and that's the whole point. It's the same way every time. When you develop a dashboard, you know what's going to happen. We can take a look at, say, one of our watches. That'd be fine. And let's take a look at how long did the web request take across those different machines. Last 24 hours is good. We don't need the legend because we only selected one thing, and we can create that. Again, it's just going to go through, it's going to pull back that information, it's going to populate it down. Once we do a refresh, we're going to see what that transactions look like, and very, very quickly get rich information into what's going on there. And it'll just take a sec to pull back. Carrying on. All right, we don't need to see a graph replaced. Basically, that's how we build those out. Now, when we take a look at how we publish these out, move across the administration here, we have this concept of user roles. And user roles are about how you give people access to things and what they're doing with all of this information. So by default, there's a whole lot of roles that are there. Are you an administrator? Are you an author? Are you an operator? All these ones that you see here are the default ones that are built in. We can create a new user role, and we will say that they are a report operator. Sounds fine to me. We can say that these are application reports, and then we get to add users into it. We can add our Contoso service owners group. These are the people that we used to deploy the applications yesterday. We can say what are the properties of those, and we create that. Excuse me. So we've created a group of which our users are now able to do that, and you can see we've got application reports there. Excuse me. When we want to be able to give access to our reports, it would help if we went to the right place. Okay, the dashboard. Take a look at the properties. That's not it. Wrong place. My apologies. Administration. Okay. So let's take a look at the identity. No. What am I doing? Oh. I'm just looking for... I'm having a mind blank right now.
Well, while you're looking for that, let me ask a broad question. We have a question. Is there an easy way for us to find machines that don't have a particular agent installed? So let's say you want to look for virtualization hosts that don't have VMM installed. You want to look for other hosts that you want to monitor that don't have the Ops Manager agent installed. It seems like there was a suggestion on here that there was a way that Configuration Manager could inventory the environment, and it could check whether different components were installed, and then using that configuration data, you should then in turn be able to roll up a report.
So you're looking for a mismatch of Operations Manager agents?
No, specifically hosts that don't have an agent installed.
Oh, okay. All right, so when you do a discovery, a network discovery, if we take a look at the device management here, we can see that we have agent managed, we have agentless managed, so these are machines that we've loaded that we are deliberately not going to manage with an agent for whatever reason. They could be in a remote network, they might be a non-Windows machine that isn't supported with the agent. There could be many reasons why not. We also have pending management, and I think there's one in here. So pending management, when you push an agent, what we get is the ability to either automatically accept an agent in terms of when it talks to operations manager, or we can put it into pending state. And what that means is this server has the agent manually installed on it, and it is configured to talk to operations manager. We have to approve that to come in, and when we right click on that, we have the option to either approve or reject that. Okay, so that's in terms of machines talking to ops manager. When we run a discovery, we can run a discovery for machines that need to be configured. And this can be a network scan in terms of here's an IP address range, go find whatever you can. It can be an Active Directory search where it's going to poll Active Directory and it's going to go and look at all of the accounts that are capable of having an agent, and then it's going to try and see if they're available on the network, and if they are, it's going to pull them all back. In fact, if we do that one, I think there's a couple of machines. We can either just do a scan Contoso, use the selected service account. It's then going to talk through and see what all those machines are. If it's already got an agent, then in the agent managed, we'll see the version of the agent and the fact that it's already on, but we now know what the agent is. If it's got no agent, then it would either be in the pending, one being pending manager, would need to discover it.
Now, is there any difference between, deploying or discovering agents, whether they're physical machines versus whether they're running inside a virtual machine?
From an operations manager point of view, there's no difference. It's an operating system that's running. The agent behaves the same based on both. We do track, though, there is an is virtualized tag, so we know which machines are virtualized and which are not. Okay, but as far as running the agent goes, there is no difference. So you can see there we did a discovery of Active Directory, and there are two machines in Active Directory that we don't know about. So we could select them, we could push the agent out to them and configure them. You can say whether they're going to be agent or agentless, okay, so we can discover them. So really what typically happens is you run either a regular discovery, or you do this as a manual process. You can do it as part of deployment as it goes through.
Great.
Okay. So that's kind of a look through the dashboards. We've got lots of different dashboards. We've talked. One thing we haven't touched on is the service level dashboards, the ability that we have to be able to, see how we're performing against our SLAs. So we have some service level objectives that are listed here. They determine what we expect to see from the application, and then the dials here tell us, well, we've got a target of 10, we're operating at 15 seconds on average, we're obviously not meeting that, so we're over into the red line. Those service level objectives are configured over here. If we take a look at the management objects, we've got service level tracking, and we've got a dinner now SLA. And this is where you can say, well, based on all that information that's coming through, what are the objectives that we want to track? And so we're tracking the shopping cart, and we can say, well, what do we expect to get? We've got a goal of 10, and we want 99.99% availability. Are we meeting that SLA? Based on the data that's coming through and all the information, it doesn't match, and that's what drives that. So it's taking, well, what is the configuration of that? If we look at that collector, it's saying that we're looking at the transaction response time from the shopping cart. So that's the rule that's created. We're just looking at the average, and we expect it to be less than 10 seconds. It's as simple as that. As we're configuring that, it's then going to do all the matching at the back end and build that up for us. So Simon, that's kind of a look through all the managing and operating of applications. We've seen how we can do it across clouds. We've seen how we can do the performance monitoring. You got any final questions coming through?
Actually, we do. There's a few specifically around AppV. I've had about 7 or 8 questions come that I've kind of pushed to the end just so we stay on target.
Okay.
Actually, first, let me jump back to another application APM question here.
Sure.
So the question is really around how do we actually collect all of the data? So, we have all of these environments, we're collecting the data. Do you have a watcher node that's running synthetic transactions? How do we go and see all this information and pull it back? Or is it simply because we've deployed an agent, we're pushing it to the operations manager node?
So this is for getting information back about the applications?
Correct. Such as page load time, JavaScript exceptions, things like that.
Okay, so it depends on the back end versus the front end. When it's server side, that's been driven by, there is an agent on the server that's running the application, and the management pack is talking directly to the agent through the APM service, and it's monitoring those transactions that are going on. Same for IIS. When you restart the service, IIS is configured in debugging mode. It's bringing a lot of that information out, and we're drilling into IIS to see what that information is. Then from a client side, we do JavaScript injection to get all of that page load time and all that. So we break it down in terms of what time was spent on graphics, what time was spent on code, how long did CSS take, how long did the page take to load. All of that information is done by APM, and it's one of the strengths of the AviCode acquisition and embedded it into Operations Manager, is it all just works if you want. You turn it on, you point it at things, and it's discovered automatically, it's configured automatically, but that's how it works, and that's what it's doing under the hood.
Great. Now, as we're talking about agents, how many agents will you typically be deploying per server or per VM? Let's assume that you have all of the different System Center components.
Sure.
And will that cause a lot of additional overhead?
One.
Okay.
So there is a management agent for the data center side. It's called, if you look in the services, you will see that there is a System Center management service. I think there's like 3 or 4 services that come together, but that agent is pulling back. So the Operations Manager agent is really the only agent that we push from a data center side, and all of that information is coming back. So configuring that, bringing it all back, that service is what runs everything. I'm not quite sure. The question I would have is around Configuration Manager. Being on the client side, I'm not sure when you configure Configuration Manager to point to a server. That's the one question that I would need to come back to you on, is what happens when you've got Configuration Manager in the mix as well as Operations Manager.
Okay, great. So now we're going to move on to AppV and ask a couple of AppV questions.
Sure.
So first of all, can you run all of the AppV roles on a single server?
All of the AppV roles. So AppV is made up, Server AppV is made up of a number of components. You have the sequencing agent, which is what's on the screen now, and that's how you capture that application. And if we go back to the front page, when you create that, it says how you want to capture that. It's going to go through and see what's going on. So capturing it is an isolated environment. You put a sequencing engine onto a clean machine. I mean, you don't want all sorts of other stuff on there. You want a nice clean capture.
You want to
minimize it. Clean machine with your base operating system good to go. You capture and you put into the bubble. Once it's in the bubble, there is a Server AppV agent that goes out, and that agent is basically the shim that sits between the operating system and the application. It mounts the application, it does all the registration with the Service Control Manager, it makes the virtual registry and all the virtual files available and all those kinds of things. So those are the only 2 components that come together, and then the service template enables us to work with those, and Ken showed you this morning. I can bring one up if we need to as well.
No, that was a great answer. What are the main differences between Server AppV and Client AppV?
Good question, and it comes up a bit. So there is actually, if you have a look in the Technic library, and I'm not punning the question, I'm going to answer it, but if you have a look in the Technic library under Virtual Machine Manager, and Server AppV is a feature of Virtual Machine Manager, there is actually a Technic article that lists the differences in a table, and there's a lot of detail there about what's different. I look at it in terms of, we do things like streaming applications at the client side. I don't really think that many customers are going to want to stream a server-side application. They kind of want to know that it's on the server and it's available. So there's things like we do streaming of application on the client side. We do not do that on the server side. On the server side, you've got things like the service, the way that we register Server AppV services with the Service Control Manager. That's a lot richer, and we capture all the local system network service and all those user accounts as well. So there's a lot of information in that Technet article. They are remarkably similar in the way that they work. There's just some nuances around things that you'd want to do in a desktop world and things that you probably wouldn't want to do in the server side, and inversely. That's how that comes together. But they are very similar.
Okay, great. Now, when you actually go and deploy Server AppV, is that deployed as part of the VMM service? Do you have other options to deploy it, maybe through Configuration Manager, through Orchestrator?
So, yes to all of the above. I'll just bring up Virtual Machine Manager as we talk about this. So, the service template model, when you have a Server AppV package installed as part of it, the first thing you want to do is run a prerequisite task of put the Server AppV agent down, because you can't mount the bubble without the agent. So as we break the service template open, what we'll see is that we actually install the Server AppV agent, then we layer down the object, and Virtual Machine Manager takes care of all of that. You can also manually install the Server AppV agent and push a package to it. That's a PowerShell commandlet, and that can be done through Orchestrator. Or you can embed it in the Configuration Manager 2012 task sequencer, can also push an application out, push a Server AppV application out as well. Okay,
excellent. Now, we have a question about running Server AppV as well as running VMs in a service template and doing updates. So I have a VM. Can I have AppV inside that VM? Can we do virtualization with virtualization? And then what happens if I want to update that VM?
Got it. Okay, so that is actually the way that it works, and that's a really good way of looking at that. So if I drill down into just the stock trader service that I've got running here and take a look at the top tier, what we'll see is that we have an application running here. So we have a tier, which is a parameter around this is the configuration and health policy for a tier. We then have a virtual machine running, and then we have a server at V application running within it. So it is virtual within virtual. Server at V, the bubble, is running on the virtual machine. It's still a one-to-one mapping of application to operating system, or you can have multiple apps on a single server, but just for argument's sake, it's a one-to-one mapping. It's just that it's virtualized rather than being deeply embedded and installed onto the operating system. What that looks like, at the back end, if we take a look at the 1.4 and open this up in the designer, what you'll see is that within each of the tiers that have been running, and we're just loading the template up now, what you'll see is the construct that is behind that, the stock trader application. Excuse me. All right, that's just loading up. Bit of load going on at the moment, obviously. Here we go. Okay, so I'll just zoom that out a little bit. Okay, so within the service, there is the application, server at V package. And take a look at the properties here, and take a look at the application configuration. Okay, so the first thing you'll see is that there's a pre-install script which is actually configuring the application, and if we take a look at the application itself, then we configure which packages it is. And Kenan showed you this morning how to go through, literally to update an application package from one version to another as a matter of browsing, changing to a different application package, and then bringing that in so we can switch it to a completely different, that's going to do a validation error because I changed it to an application that's not part of that tier, but we did that. So we've now changed the application package and it's there. We have a pre-install script that we talked about installing the server at V agent, and here is the script that is running. So there's a pre-install script before we even start putting an app down. We need the server at V agent there. So server at V, it is there. There is the package that installs server at V. There is the command line that does that. It's just a script that is a silent script of an installation, and once that's available, then it will drop the application down and configure it.
Great. Well, we have two additional installation-related questions. First of all, do I need to install everything on a single drive, such as the Q drive, which is apparently what Desktop App V recommends to do?
Okay, so the Q drive and the way that it mounts that, that is something that is kind of silent behind the scenes. When you do the server at V packaging, and when we broke out that application, if I go back to the one that we had open, you'll actually closed it. Okay, let's open that back up again. Let's modify that existing package. All right, let's bring that up. So you can see the virtual file system that it's referring to C. Okay, so there is a virtual file system that is mounted, but it will refer to the C drive there. So I think, I'm not sure of the exact details, but I believe that's one of the slight differences with the desktop desktop version versus the server version. But take a look at the TechNet content that's there. There's a lot of guidance on how to do this. There's a lot of guidance on the do's and don'ts and the best practices, and also blogs.technet.com/server at V. There's a lot of examples on how to sequence applications. Derek Isoka, who works on the product team, has done a lot of work around sequencing applications, and at recent events we've published a lot of content as well about how to do that. So there's a lot of content out there, a lot of how-to guides and examples of the do's and don'ts. But certainly the Q drive, I think that operates on the desktop side. I haven't seen that on the server side.
Now, as we're talking about, managing other types of virtualization components, what about managing virtual desktops? What's our solution here?
Okay, so that's a good philosophical question, Simon. So the question I would have, and every time I ask this question, I kind of get a different answer, is VDI, which is effectively the remote desktop or the virtual desktop solution, is that desktop management or is that server management? Because it's a desktop application, but it's running on a server hypervisor, right?
Great question.
And so it's a very good philosophical question, and I don't think there's a right or wrong answer to that. Some organizations, they're going to take a VDI image and run that as desktop management. It just happens to be on Hyper-V, so what? Inversely, other organizations are going to look at that as a server management stack, and they're going to look at that. from a System Center point of view, Virtual Machine Manager can host virtual machines that are running Windows. Okay?
Server,
and client.
Whatever.
And then we've got Configuration Manager, which does a lot of that desktop management. So between Configuration Manager and Virtual Machine Manager, you've got a lot of that capability to do desktop management. We also have great partners in Citrix who do a lot of things that extend our solution even further, going to a lot more platforms and adding in a lot of the brokering services today. So with System Center 2012, we provide a lot of capability to manage virtual machines in Virtual Machine Manager. We have Configuration Manager from a desktop management point of view, and then we have partners as well like Citrix who extend that capability.
Great. So final App V question I have. How exactly is it licensed?
So Server App V is a part of Virtual Machine Manager, which is a part of System Center 2012. So with the licensing changes that we made with System Center 2012, we have the standard and the Data Center edition, the big and the small effectively, standard targeted at the physical machines, Data Center targeted at the virtual platforms. Once you own that, you have all of System Center 2012, which includes Server App V.
Okay, that's excellent. So next question I have is there any type of best practice analyzer to go and scan my entire environment, my private cloud? And what exactly is System Center Advisor? How does that fit in?
Okay. So the best practice analyzers, I believe they are being updated for System Center 2012, and they will become available. So I don't have any further details to share at the moment, but you can rest assured that they will be done. Advisor is a hosted service that's available that does the best practice analyzer, and it brings in all of the learnings that we get from running in the big scale environments, and effectively has an agent that runs on premise, and it gets that information back up into Advisor, which is running up in the cloud. Okay, and so basically it is a hosted service to do the best practice analyzing. It's going to check to see if your patches are up to date. It's going to check to make sure that your configuration's okay and all those kinds of things, pulling back all of that telemetry data that we have about patch management, about availability, configuration, and best practices, but it just runs as a service up in Windows Azure.
Okay, excellent. And actually, one more question around application monitoring. Do we have any type of built-in application stress testing tools?
Application stress testing tools? Not specifically, no.
Okay.
I think that there are ways to put load on. We don't have a load sim, if you will, built into our products today. It's a very good feature request. Someone want to put that in as a DCR and mount that in? Absolutely, we'd love to hear that. We don't today.
Okay, excellent. So final question, I believe. Might be some more coming in. The final question, I believe. If I want to go and try out System Center 2012, meaning I wanted to go deploy it in a test environment, you know, non-production,
Sure.
I have limited hardware. What's kind of the smallest subset that I can install all of these components? Can I do it on one physical host with multiple VMs? You know, what's kind of a poor man's solution for going and deploying all these
Sure.
components?
I'm laughing to me because we had this conversation in our team very recently, and It was like from a lab and a demo point of view, when we want to do the virtual labs on TechNet and those kinds of things, like how small can we make this thing? And the answer is it depends, and I don't mean that as a glib answer, but to get a full working private cloud with every possible scenario running in it is quite a big piece of infrastructure, because you've got all of these scenarios. Everything you've heard in the last 2 days would be lit up and working and functioning, and that's great when you want to try everything. But you've probably got target problems and you've probably got target capabilities that are really relevant to you. So I think the smallest subset we came up with was 7 virtual machines.
Okay.
And that is like a domain controller, a SQL box, and then the individual components configured in ways that they all work together and give you, a relative ability to do that. It all depends what load you're going to put on that. If you use the unified installer, which allows you to do greenfields implementation, it's very segmented, so each component has its own SQL server and those kinds of things, and gives you a vanilla installation of everything good to go, then that's actually quite lightweight to stand up and run. But when you start using it, then that's when the load comes on, and it really depends what you're doing. If you have a very basic application and you've got one management pack and operations manager and that's all you're doing, that's not adding much load. But if you bring a full service template in and you've got lots of deployments going on and it's getting pretty heavy, you've got lots of SQL, lots of applications and lots of load, you start using Service Manager and doing orchestrations and building that out, that's going to become more and more load on your hardware. So you can start small. You can start by implementing the individual components. You can start by building out those base levels. Get VMM installed, start managing your hypervisors, build some single tier service templates out, use those to build out your virtual machines, start pushing agents around in your dev environment. You can do that and start relatively small. But it is fair to say when you light up every single scenario like we've done in the private cloud immersion days and those kinds of things, that's every scenario that we could possibly run. That's pretty big. That's a lot of infrastructure. That's a full enterprise running in a VM set. That's going to get heavy. But absolutely, start small, install the bits that you want, and then hydrate the environment to enable you to do that.
Excellent. Well, thank you so much for joining us. We've had some great feedback, had some great questions. Thanks a lot for your knowledge. Well, as we wrap it up, I do want to thank all of you for joining us over the course of the 2 days. These videos will be made available in the near future. You can find them on TechNet, and you should be able to find them on the Microsoft Virtual Academy, www.microsoftvirtualacademy.com. Make sure you also check out some other upcoming events. We have upcoming conferences with MMS and TechEd coming up. And additionally, make sure that you check out some of the upcoming private cloud evaluations coming out from Microsoft Learning. So if you really want to test your knowledge, apply what we've learned here, go try these certifications. You can become a fully certified Microsoft private cloud guy. And additionally, go and try the software today. All of these products are available on TechNet Evaluation Center, so you could download them. We have the unified installer to simplify how you actually deploy them. And you can now even download them as a single package. So rather than downloading all of these as separate products, single package download, so it's easy for you to go and try it out. If you want to avoid downloading it and you just want to jump straight into a component like Ops Manager 2012, try the TechNet Virtual Labs as well. Those are already up and available today and allow you to directly launch a machine that already has the components installed. Well, as we wrap this up, we certainly hope that you enjoyed learning all about the Microsoft Private Cloud, how to configure it, how to manage it, how to operate it, and then how to look at the different layers of the private cloud as Microsoft's approaching it, from the private cloud infrastructure and infrastructure components to the application management and that service delivery and automation layer that sits between, that really translates the end user requirements to the underlying hardware. With that, we want to thank you. Please complete the evaluation survey, send us feedback, and if you have any additional questions, go onto the TechNet forums, leave your questions in the various System Center blogs, in the various System Center forums, and we will respond to the questions as quick as we can. Thank you. Goodbye.